Hello students, I am Dr. Gajendra Purohit and you are watching my YouTube channel where I upload videos for engineering, mathematics and B.Sc if you are preparing for any competitive exam. Where higher math is asked, then my channel is very helpful for you. And here you can access this I-tab to refer and watch my previous videos. I want to inform you that I am uploading new content on differential equations. It will be visible here and you can also find the previous content in the link provided in the description. In this lecture, I will explain the particular integral in which you will be able to solve the special type of functions such as questions like cot x, e power x, tan x, sec x and also cosec. Therefore, let's see how we solve these questions. As you can observe, if we have a differential equation given like this here, if x is a function and you need to determine its particular integral, you will find 1 by d minus alpha x. The minus alpha present will go inside e to the power of minus alpha x, while its opposite power will come outside into dx. If there is a plus here, then plus e to the power alpha x will go inside and minus 1 will come outside. This needs to be noted if we have two steps here. If we have d minus alpha and d minus beta, then first we will solve d minus beta like this. Then we'll multiply d minus alpha by the answer. I'll explain with an example. Let's say we have this question d minus 1 and y is equal to e to the power of 2x. And we know that the particular integral of this is e to the power 2x upon d minus 1. Moreover, I explained the method where you substitute 2 for d, right? So the answer we get is e to the power 2x upon 2 minus 1, meaning e to the power of 2x upon 1. We know this. And if I apply this method, then in that case, here we will be doing y is equal to e to the power 2x, and this power which is given here, the same power of 1 will be taken. If it's minus, it will become minus x, and if that's minus, then it becomes plus. And into dx, then y is equal to e to the power x. Here at this point, it comes out to be e power x dx. We know that the integration of it is e to the power x itself. Thus, here we get e to the power x twice, and then y is equal to e to the power 2x. Notice that this is also its pi, and by this way it is also its pi. So the concept remains unchanged, and it is essential to grasp this. I will provide some important examples from an exam perspective. Now let's see how will we attempt this question first. We will put m wherever d is. And we will try to find its CF. Therefore, we know that the value of m is minus 1 and minus 2. Students, the CF of this equation will be c1 e to the power minus x and c2 e to the power minus 2x. When we discuss pi, then y is equal to e power x, and if we divide this, then we know that its factor will be d plus 1 into d plus 2. In this, we consider d plus 1 and then we take d plus 2 out. And this is e to the power x upon d plus 1. For d plus 1, we will use the formula I mentioned. As we are already aware that here we have integration sign. E to the power x, and this is a positive power, so it will be e power x. And its negative power will come out. So keep this in mind. Here we have plus, so e power positive x here, and e to the power minus x will come out. We will use the same concept here. We will assume e to the power x as t. In this step, this e to the power x dx will be obtained as dt in here, clear students. And here we will get y is equal to 1 upon d plus 2 e to the power minus x. Therefore, we will get e to the power t, and this will be dt, right? We know that its integration with respect to t is e to the power minus x d plus 2. The integration of this will be e to the power t. In place of e power t, we put back the value, so we get e power x. At this point, we will proceed to use for d plus 2 again. And if it's used for d plus 2, then we will incorporate it for the whole thing here. So in the next step, we will use it for d plus 2. Then y is equal to the integration of e to the power minus x. And then further, e raised to the power x, and we have plus here. So we will get e to the power 2x, and outside of it, we will get e to the power minus 2x into dx here. Y equals e power minus 2x. Here x in 2x is eliminated. We will get e to the power x, e to the power x dx, and we have to consider what we assumed. We will take similar assumptions. We will consider e power x as t, so e power x dx will become dt. Further here, we get y is equal to e power minus 2x. Thus, we obtain e to the power t here, right? And e to the power x dx will be what? It will be dt. So we will integrate this. And as we are already aware that its integration is e to the power t. And also plus c, but it can be ignored in the pi anyway. E to the power minus 2x, and it will be e to the power x. And here we get the particular integral of this. So the final answer will be CF plus pi. This is how we solve this question here. And it's very simple. Let's look at the next question. If we discuss it, then d square plus a square y is equal to sec a x. And this is frequently asked in exams. We are given m square plus a square is equal to 0. First, we will find its CF. it is plus minus a iota. Therefore, the complementary function will be y equals c1 cos ax plus c2 sin ax. This can be done very easily using variation of parameters. You can also watch the video of this on iTab. Here we will find its pi. To find the pi, what will we do? We will take this to the denominator. Thus we get sec ax divided by d square plus a square. We write it as d plus a iota multiplied by d minus a iota. We need to keep that in mind. Now we will perform its partial fraction. We get 1 upon d plus a iota into d minus a iota. We will perform its partial fraction, so we get a upon. Further, we will obtain d plus a iota plus b upon d minus a iota. How do we solve for a here? What should we substitute for d to make a 0? Minus a iota. This minus a iota will be placed here, so minus a iota and minus a iota. So students, the value of a will be 1 upon minus 2a iota. If you hide this and place minus a iota here, then this expression will be minus 2a iota. Similarly, we need to find b. What should we substitute for d to make b 0? It's a iota. Hide this and replace it here, and the value of b will be 1 upon 2a iota. Then we will take this value and put it here. So we know we will get minus 2a iota. And further we get d plus a iota. And its value will be 1 upon 2a iota and then d minus a iota. Now we will take this value and place it here. So in this particular expression, I will take 1 upon 2a iota as common. And this, the positive one, is written ahead. And this will be written after that. And 1 upon minus d plus a iota. I'll write sec ax here in the expression. I just used partial fractions and added sec ax at the end. We'll multiply sec ax inside. So consequently, we will get y is equal to 2a iota. And further in the expression, we will get sec ax upon d minus a iota minus. And here we get sec ax upon d plus a iota, right? Now we will deal with this. I'll change the color a bit so that you can understand clearly. And further, we will get y is equal to 1 upon 2a iota. We will integrate this because we have d minus a iota here, and I just explained to you how to find the pi. So we get sec ax, and since we get minus here, so e power minus iota ax. And this positive power will be moved in front and into dx. Similarly, there is a minus in middle, so use minus here. It will be minus here. And here we have plus. Then we get e to the power. It is minus a iota x, and we have plus power inside. So we have e to the power a iota x and sec x dx. Students, this way we have its value here. Now, in the next step, y is equal to 1 upon 2a iota. Subsequently, when we proceed to put the value here, we will be getting a iota x. And this e to the power a iota x can be written as cos ax minus iota sin ax. And this sec ax, we can write this as cos ax and divide. This is dx. Similarly, when we will write e to the power minus a iota x, we do the same thing here. Therefore, we will be getting cos ax plus iota sin ax divided by this sec x will be written as cos ax into dx. That's the value we get. Now, subsequently here y is equal to 1 upon 2a iota e power a iota x. And for this integration, these cos will be divided anyway. Therefore, here we will get 1 minus iota tan ax dx, right? Similarly, when we discuss this, it will be e power minus a iota x. Here cos divided by cos becomes 1. And then we will get plus iota tan ax dx in this expression. We know that the integration of tan is log sec x. So 1 upon 2a iota, if we integrate this, then firstly, e power a iota x and its integration would be x. And here it is minus iota. It will be e to the power a iota x and log sec ax. And ax will be 1 upon a. Similarly, 1 will become x, so we will get e to the power minus iota ax, and this x will be here. Integrating this, the minus sign goes inside. Iota e to the power a iota x upon a. And this one will become log sec ax as well. Now observe that we'll write these terms together in the equation. Y is equal to 1 upon 2a iota, and we write this term together and take x common. This will be e to the power a iota x minus e to the power minus a iota x. I took x common, clear? In the same way here, what we have as common, we have log sec ax as it is in minus. So this will come out. Therefore, it will be minus iota a log. If sec ax is common, then we will be getting e to the power a iota x, and since both are minus, we will get e to the power minus a iota x at this point. Students, we have a formula, and this formula needs to be understood. So the formula is e to the power a iota x plus e to the power minus a iota x upon 2, and it has a formula which is cos ax and e to the power plus a iota x minus e to the power minus a iota x upon 2 iota. And the value of this expression is sin ax, right? This is the formula we have, e to the power of a iota x, and this minus, so 2 will be multiplied by this. Here we have this minus. So from here 2 iota will come in the multiplication, right? Let's multiply this 2 iota first, which will be the best thing to do here. The resulting equation shows 1 upon a. And further we will be getting e to the power iota ax minus e to the power minus iota x upon 2 iota will be here. And into x. Students, it will be minus 1. Thus when we multiply 2 iota inside, the iota will cancel with iota. And in this expression, the value that we will be obtaining is, since we are multiplying 2 iota inside, this will become 1 upon a log sec ax, then e to the power iota ax plus e to the power minus iota ax upon 2. When we put its value here, there is not enough space here, so I will clean this up because our work is done, right? So I am writing here in this space and changing color so that you can understand. Now we will place the value. Now please pay attention, the value of this expression y is equal to, I told that it would be sin ax, so here it will be 1 upon a, and here we will be getting x sin ax, and here in this expression we will get minus 1 upon a, and here we will obtain log sec x, and here we will be getting cos ax, and consequently we get cos ax, and here we have log sec ax. So students, we will multiply this 1 upon a, so y is equal to x sin ax upon a, and minus 1 upon a square cos ax, and sometimes we get log cos here. If we get cos, then this minus changes to plus. So you can write log cos ax, and the final answer of this will be y is equal to cf plus pi. This way, we can solve questions like this very easily. Let's consider this. This is the same as the previous. We will do m square plus a square equals 0. This implies m is equal to plus minus a iota. So the cf will be c1 cos ax plus c2 sin ax, and here we will find the pi of this. So to find the pi of this, we will do tan ax divided by d square plus a square, and we simplify this a bit, it will become tan ax. We will write this as d plus a iota into d minus a iota. Remember, I just explained its partial fraction, 1 upon the value of d plus a iota multiplied by d minus a iota that I explained to you. As I mentioned earlier, we obtain a upon, and then d plus a iota plus b upon d minus a iota. Then I told you value of a we get is minus 1 upon 2 a iota, 1 upon d plus a iota, and its value is 1 upon. Just before this question, I explained exactly the same thing to you. Now we will take this value and put it here. So here this y is equal to 1 upon 2 a iota is written in front. Write the negative term in front and the positive term later. There is a minus sign in between. So you have to put the minus sign. There is a minus sign in between. Subsequently, this will be d plus a iota, and further this will be tan ax, right? Now do multiplication of this tan ax here. Y is equal to 1 upon 2 a iota, and this tan ax is multiplied and goes inside. Therefore, we get tan ax divided by d minus a iota. Here we will be getting minus tan ax upon d plus a iota, right students? You can solve this expression comfortably. So I'm explaining one here and you have to do the second one similarly. This is 2a iota, and here we get e to the power minus a iota x. And here we get tan ax, and further we get e to the power a iota x and dx, and then minus. And doing it here gives us d to the power a iota x, and we get its opposite minus a iota x. Then here we will be getting tan ax dx, right? In this case, we will put e to the power a iota x as the value. And in this process, we get y is equal to 1 upon 2a iota. The value that we will get here, that will be e to the power a iota x. And after solving it, if we place this here, then this expression will be cos ax minus iota sine ax into. Here we will get tan ax dx in this expression. Plus, sorry, I wrote it wrong here, it should be minus. So it's minus here, and also we have the same thing at this place. What do we have? E to the power minus a iota x, the whole thing, then the integration of. And at this point in the equation, we have cos ax plus iota sine ax into. And here we are obtaining tan ax, right, and into dx. Therefore, that's the value we get. Now we will simplify this. So y is equal to 1 upon 2a iota. This will become e to the power of a iota x When we multiply tan x, then the value of tan is sine by cos. So the cos will cancel out with the cos in the equation. And at this point, the value that we will be obtaining is sine ax, right? When we do sine divided by cos, then we will get iota sine square ax upon cos ax, right? In this way, here we write its value. Similarly, here the same term will appear. I can solve it for you. That one will also be solved this way. So y will be equal to 1 upon 2a iota. Then it will be a iota x. Here we get sine ax and we will further solve this expression. And here we have dx and I am separating this. Here we have this iota. Notice that in the same way, this will also be e to the power minus a iota x. We have less space here. We have 10 here. Since it is sine by cos, so we know we will get sine ax plus iota, and here we will obtain sine square ax, right? Upon cos ax into dx. So that is the value that we will be obtaining at this place. We know that this is 10. Now here we have this iota. We have sine square. So I can write this as 1 minus cos square ax upon cos ax and into dx. So there is no difference here, just instead of iota, there is plus iota here, which will be handled later. Okay, let me just explain. It's e to the power minus a iota x. The next term that will come here will be sine ax dx and plus instead of minus. In this we will get 1 minus cos square ax upon cos ax dx in this expression. That's the value we will be obtaining here. Now what will be its value? 2a iota is taken outside. Here the integration of cos will be, as you will observe in this, a iota x. And here at this point, this will be, sorry students, here in this place, the integration of sine will be minus and. Okay, let's put this value here. Is this clear? It will be cos ax upon a. Now iota is present here and it will be 1 upon cos ax. So cos ax will go to the numerator, making it sec ax. What is the integration of sec ax in this case? Log. This will be sec ax plus tan ax, and this will be again 1 upon a here. That's the value we get. Clear? And in the next step, these cos will be cancelled out. Now what will be the value of cos here? As we have cos here in this expression, and minus becomes plus, as it is cos here, so let's keep the minus outside. I am removing this part from the board because it's getting too long. We need some space on the board to solve. Now, let's move to this particular expression here. It will be sec ax plus tan ax. Then, when we solve this equation here, so we get minus cos. And the integration of cos is sine ax upon a. That will be the value here, and we will close the bracket of this here. Now, when we discuss it, so it will be minus e to the power minus a iota x. And then in the next step, we will perform its integration. So I'm going to put a bracket here. We know that the integration of sine here will be minus cos ax upon a plus iota. And students, we know that the value of this expression of 1 upon cos will be log sec x plus. It's tan ax, and here we get 1 upon a. Here we have minus. Thus we get the value which will be minus 1 upon cos x. Then we get its integration, which is sine ax upon a. In this way, we get the value of this. Now, students, at this point, please pay attention and try to understand this expression. This is y is equal to 1 upon 2a iota, and we have cos ax upon a here, and minus will be plus here. Therefore, let's try to solve this equation here. We have cos ax upon a and also minus sine ax upon a. And here we have minus. So I think this will definitely give us some value. In the next step, we solve this. Thus, we get cos ax upon a and e to the power a iota x. Minus e to the power minus a iota x in this expression. Correct? Here, let's get this expression solved as well. We have minus sine ax upon a. It's the same there as well. So minus sine ax upon a will be taken out as common. So we get e to the power a iota x. And these minus and minus will become plus. Now this gives us e power minus a iota x, since we are taking out minus as a common factor here. Therefore, this will also be minus here. We have sine ax and minus becomes plus. So we will get iota here, since we got to iota at these places in multiplication. This will be the value that we will get here. Then here you can see this term and this term, we have them as they are. And moreover, it's appearing as negative. This one also appears as negative. Is that clear? Now we will take out minus as a common, and it becomes minus iota. Log sec ax plus, and further in the expression we will get tan ax, and the value we get will be e to the power iota ax. And since we have this term as negative here in the expression, and this is also negative, we will take both as plus. E to the power iota ax plus e to the power minus iota ax, this is the value that we will get when we will multiply this 2 iota a inside. Then let me tell you, in this case, when we multiply 2 iota, then after multiplying, we take 1 upon a outside. And in the next step, we get minus cos ax upon a and power a iota x minus e power minus a iota x upon. And 2 iota plus, when this 2 iota goes inside, iota cancels out with iota and we get sin ax upon a and e to the power a iota x plus e to the power minus a iota x upon 2. When this 2 iota goes in, the iota will cancel out with the iota. So minus log sec ax plus tan ax. We also get 1 upon a here in the expression because we got upon a here and here as well. Is that understood? Now we will be getting e power a iota x plus e to the power minus a iota x upon 2. We know that the value of this is cos and its value is sine. As you can observe, these are the same. So I will write it here. Therefore 1 upon a, and we will get cos ax upon a, and here we will get sin ax. And further we will obtain sin ax upon a, and here we will get cos ax and minus. Here it will be 1 upon a log sec ax plus tan ax, and students, we will obtain its value, which is cos ax. As you can see here that these values will be cancelled. And when you multiply here, thus we have 1 upon a square. Let me first make space to simplify. Let me clear this part here on the board. I will solve here in this space and find the value. Therefore, the value that we will obtain will be here. Let me write it in different color. Here this is y, and this 1 upon a will be multiplied by this 1 upon a. So we get minus 1 upon a square. Cos ax will be written first, and this will be log sec ax plus tan ax. Therefore, this will be the pi of this equation. And the final answer that we get will be y is equal to CF plus pi. And with this method, we can solve such type of questions. That's how we solve them. So let's see the next. We have d plus 1y equal to e to the power x. So what is its pi? So solve this question with the method I explained, and also please let me know how long it took you to solve this question. Also, please let me know your views about the new series. Please do comment about it. And lastly, the 2.0 videos that I'm uploading on the differential equations can be seen here, and here is my old differential equations playlist. Let me know about your views on my videos. Please tell me about them and be sure to give your answer in the comment box. Thank you all. Bye.